Good evening, everyone. Welcome back to our sessions on Python for AI. So we have understood all the fundamental topics, right? Under Python, we have understood all the fundamental topics like data types, then flow control statements. Yes. Then functions. And what is the last topic that we have discussed? We have also discussed modules and packages, right? Yes. So today we are going to learn visualizing data using Python. Okay, so we are going to understand data visualization using Python. So whatever concepts that we have learned so far, we'll be using all the concepts, guys. Okay, so first of all, what do you mean by visualization? A simple question. What do you mean by visualization? Come on, guys. What do you mean by visualization? We know what is data. Data is nothing but any information. Any piece of information is nothing but data. So this data, if I am able to represent in the form of pictures, graphs, that is called as visualization. So in today's class, we are going to understand data visualization using Python. Okay, so we'll be using Python and we will visualize the data where we will be understanding multiple multiple plots, multiple visuals. Yes, it's nothing but graphical representation. Representing the data and visualizing it. Yes. So, what are the plots that we are going to learn in today's class is, we'll be starting with bar plot. For each and every plot, we'll understand the purpose. What is the purpose of using bar plot? Why should we use? Okay, how bar plot helps us will be understood. Then we'll take a use case and we'll apply bar plot on it. We'll visualize a bar plot on the data. Then followed by histogram. Followed by histogram. In the same way, yes. Next to histogram, we'll understand box plot. We'll understand box plot. What is box plot? What is the purpose of using box plot? Okay, so the questions will be answered for box plot. And finally, we also have scatter plot. Okay, so these are the four important plots that we will be understanding in this session. Apart from it, we also have QQ plot. Quantile plot is the plot that we'll be understanding. Then count plot. We have violin plot, so on. Okay, almost we are going to learn 8 to 10 plots in this session. But our main focus will be on the first 4 plots. Understanding the purpose, and we are going to work out on use cases. That will be the agenda for the day. I hope it's clear, right? So let me start the session. Right. You see here, what are we doing in line number 2? What is this? What is a line of code that we have? Import pandas as PD. So pandas is a package. Pandas is a package. What do you mean by package, guys? What is package in Python? I want everyone to respond. We have understood what is a package in the last session, right? So what is package? Pandas is a package. Fine, accepted. I'm importing pandas. Done. But what is a package, first of all? Package is nothing but collection of modules. It is nothing but collection of modules. It's a collection of modules which provides reusability of code across environments, drives, folders. Yes, collection of modules. How I can reuse a module? We have understood the steps. The first step is using SYS module. I can import SYS module and using SYS module I can do it. This is temporary. What is the permanent step? Using environment variables. Right? So these are the two different approaches using which we are going to use packages concept. I hope it's clear. Right. So what are we doing in line number 2, guys? I'm importing a package called pandas. I'm importing a package called pandas. So where do I have pandas? In my local machine. In my PC, I have pandas. Pandas is what? Pandas is a package. So package means, do you mean a folder? Yes, it's a folder. Tell me the steps to create a package. What are the steps do we have in Python to create a package? How can I create a package? Come on, guys. How can I create a package? I can create a package using 3 steps. What are they? The first one is creating an empty folder. Then, what is the second step? We have to place an empty file. What is that empty file called? Underscore underscore init underscore underscore dot py. Create an empty folder, okay, in which we have to place a file called underscore underscore init underscore underscore dot py. Done. Then next to it, I can place multiple .py files. What are these .py files called? Modules. These are called modules. So this is how we create a package. So that means I can understand that pandas is a package in which it is a folder which contains this file underscore underscore init underscore underscore dot py file. Along with, we will also have .py files. There are .py files which are called modules. So whatever you learn, just map with the case so that whatever you learn will be memorized for long time. Hope it's clear. So this is how, pandas is also made, prepared. right? So what am I doing? I'm importing a package called pandas. But what is the use of pandas? First of all, what is pandas? Pandas is a package which helps us for data manipulation. Data manipulation. Okay. In order to manipulate the data, we are going to use a package called pandas. That's it, right? Yes. But hold on. How can I manipulate the data using pandas? The question raises again. Here we have .py files called modules. Yes. So within module, what you will have? Module is a collection of functions, variables, and classes. Module is a collection of functions, variables, and classes. So that means whatever the functions or the class objects, the variables that we have, by using these, we are going to manipulate the data. That is how you have to interpret. Clear? So pandas is a package and I'm importing entire package. I'm importing entire package. From where? From the local machine. Okay, this folder will be imported to Python's memory. How am I able to do it? I'm able to do it using a keyword called import. Yesterday, if you remember, we have discussed modules topic, right? In modules topic, how are we able to use modules? We were able to use modules using import keyword, right? I can use a module using import keyword. Initially, I import the module in any other program. Okay. And I can successfully use that particular module. In the same way, I'm importing a package. Okay. I'm importing the whole folder. The whole folder is being imported. Import is a keyword. Then I'm also providing a alias name to pandas. I'm giving an alias name to pandas. What is an alias name? A shortcut name. A nickname. Right? So what is the nickname that we are giving to pandas? The pandas, we are giving the nickname as PD. Why PD? PD okay. But why PD? Can't I keep it as KD? Yes, you can. Can't I keep it as AD or VD? Anything is accepted. Anything is accepted. Even you can give an alias name as NEUT. It is accepted, guys. The purpose of giving alias name is, instead of using pandas every time, I can directly use a shortcut name, PD, VD or whatever it might be. But again the question comes, but why only PD? Why not KD, AD or VD? Anything. Because why only PD is, PD represents pandas universally. Universally. You go across the globe, pandas nickname is PD, guys. Across the planet, you go anywhere, any place, PD is the alias name given to pandas. So what does PD represent is universal standard. It is universal standard for pandas. That is why we give PD, so that even though if your code, if your .py file is shared across your connections, your team, they can easily understand that PD represents pandas. Instead of PD, if I keep it as NEUT, still it executes. It executes. But when I share this .py file across my team, okay, across my connections, whomever it might be. So they have to refer back. What is this NUT? They have to come back and they have to start from line 1. That is why PD is representing universal standard. Everyone who belongs to the, space of Python, field of Python, they can easily interpret that PD represents pandas. It is universal standard. That doesn't mean every time PD only should be used. That's what I'm telling you. You give any shortcut name, it executes. But for interpretability, for understanding, for making it clear, we go with universal standard, that is PD. I hope it's clear, right? So I'm using two keywords called import and as to import a package and give an alias name, right? So I hope the line 2 is clear. What is the purpose of pandas? Why do we use pandas? The purpose of pandas. Come on, guys. Why are we importing pandas? Why am I doing it? For data manipulation. In order to manipulate the data, we use a package called pandas for data manipulation. Okay, your answer should be for data manipulation, we use pandas package. Right. So let me execute line number 2 and focus on the console. Is it done? Yes, it is. It is. Fine. But the question rises. What will be the question? Pandas is a package which is used for data manipulation, right? But what for practice, you guys, as a part of practice session, if you want to use pandas, if you write the same code, will it execute? Will the same line of code execute in your system or not? Will it execute the same line of code? Import pandas as PD. The answer is may or may not. Why? Because are you using the same IDE like me? Are you using same spider IDE? If yes, this line of code will execute. What if you are not using, the same IDE? But first of all, will this line of code execute only in spider? No. No. The answer is no. Then suppose I'm going to use a different IDE like Jupyter Notebook, VS Code, PyCharm, Google Colab. There are multiple IDEs, right? So assume that I'm using a different IDE altogether. So will this line of code, will it execute? That's what, may or may not. How can I can confirm that this line of code will execute or not? First of all, you have to ensure that this folder is present in your system. Pandas is what? Pandas is a package. Package means folder. Is this folder available in your PC? If yes, this line will execute. What if this folder, this package is not available? Then it will not execute. Okay. Then how should I have this folder in my PC? How should I have this pandas package in PC? Is we use a tool called pip. We use a tool called pip. Okay. So Using pip, we install packages. We install modules. Okay, so the command will be pip install package name or pip install module name. Assume that if you have executed this line of code and after executing this code, this line of code, if you have got a name error, module not found error. Okay, assume that you got module not found error. What does module not found error means? It means that pandas is not present in your PC, guys. No, that is why you are getting this error. You'll get an error like no module named pandas. No. Then what you have to do? You have to install it. You have to install it. What is the command? The command is pip install package name. You go to the console, you keep it here. Pip install pandas. If you keep this line of code in the console and click on enter, this will install pandas. Post installing the pandas, ensure that you restart your kernel. Okay, once if you restart your kernel, you can execute the line of code. But again, the question raises. So, in order to install a package, will this be the command every time? Yes, this will be the command. So, for each and every package, will this agree? Will it be the same? Yes, the command will be same, guys. But, you cannot blindly follow this command. What? I cannot use this command as it is? No. Assume there is a package like ABC. The name of the package is ABC. Are you sure the name of this package is ABC, right? So are you sure about the case of this ABC? ABC can also be in this way. ABC can be in uppercase, can be in proper case, can also be in camel case, lower case. Yes. Why am I discussing everything is Python is case sensitive. Python is case sensitive. So what does it mean? It means when you don't use the same case as is, you'll get exceptions, errors. And this is a never-ending process. Are you sure that when you are installing pandas, is pandas in proper case or pandas is in lower case or pandas is in entire capital case? What should I follow? What should I keep in this line of code? Right? Python is case sensitive. Should I go with proper case pandas or lower case pandas or uppercase pandas? We also have camel keys. So when there are multiple options, what you are going to try? This is not luck, right? You will encounter errors. Then what should I do? There is a repository called PyPI. There is a repository called PyPI. Every time you have to, go through this repository. In order to get this command, visit this repository and get the command. How should I do it? Hold on, let me talk about it. See. Okay, assume that I don't have pandas in my PC. Okay, so what should I do? I have to install pandas? Yes. So the best practice is visiting .pypi repository. So open any of the browser. You open any of the browser and keep it as pandas space pypi. Pypi. Py. Click on enter. When you click on enter, you will see this repository pypi.org. Okay, then click on the first link, pandas. You see here? So pandas, and next to it there is a number 2.2.3, which represents the version of pandas. So this is the PyP repository of pandas, guys. Whenever you are free, just go through it. You can go through the release history. Each and every release have a date, and what are the updates that are present. Everything will be present here. Each and everything is present in this document. Anyways, it's not the time to understand everything, right? So for understanding what is pandas, the abbreviation, Powerful Python Data Analysis Toolkit. Okay, what is it? Pandas is a Python package that provides fast, flexible, and expressive data structures. So the detailed explanation for pandas, we have it here. Whatever might be the package, you copy the command and go back to your spider. Whatever the IDE that you are using, you can go back to it. But here you will find the command pip install pandas. What is the case of pandas? It is in lowercase. So even though if I have tried, that would have executed. Even though if I have tried installing pandas in lowercase, that would execute. Why? Because it is seen. Pandas, we have it in lowercase only, guys. So even though if you have given a try, that would have executed. Post pasting the command, click on enter. So that will install pandas. That will install pandas. What do I have? The message that I got is requirement already satisfied. I already have pandas. Where do I have pandas? Pandas in C drive at this location. Under users, user Anaconda 3 lib site packages. Okay, so this is the place where I have pandas. And what is the version of my pandas? 1.4.4. What is the version that is the recent version? 2.2.3. 2.2.3. Okay, so either I can update pandas, if not I can continue. I can continue because I already have pandas. Right? So in this case, it says that I already have pandas. So that is the reason even when I try to import it, I'm not getting any error. Pandas got imported. Where it got imported? It got imported to my sessions memory. Python's memory, pandas got imported from local machine. Fine. But why don't you give an example for a package name which has mixed characters, mixed case characters? Yes, I already have an example for you guys. You see here, there is a package called SQLAlchemy. There is a package called SQLAlchemy. The purpose of SQLAlchemy is SQLAlchemy helps us to integrate Python and database. Any relational database management system can be integrated with Python. How? When you have this SQLAlchemy in your PC, this is a package. This is a package which helps us to integrate both Python and DB. What kind of DB? Especially relational database management system, RDBMS system. So I can integrate both. I can establish a connection between Python and RDBMS system. But when can you do it? When you have this package. Okay, so assume that you are trying to establish a connection between Python and RDBMS system, and you came to know that SQLAlchemy is the package that you should have in your PC. in your system. So, you have to install it first of all. Before importing, you have to install it. Guys, don't get confused. Installing is different. Importing is different. Installing we do only once for every environment. But importing upon the requirement from project to project, we can import n number of times. Importing is different. Installing is different. In order to import, first of all, we should install it. So, I'll install SQLAlchemy. What is the command? We know that to install, the command is pip install package name. So I'll keep it as pip install. What is the package name? SQLAlchemy. SQLAlchemy. But will this execute? For sure, it will not execute. It will not execute. Why? I'm giving the same command, right? Whatever the command that we have discussed for pandas, I'm using the same command. But why it will not execute is, you observe the case of SQLAlchemy. Is it uppercase? No. Is it lowercase? No. It is of mixed case. SQLAlchemy is present in mixed case. So if you want me to prove it, go inside, click on the link. Now you see the command for installing SQLAlchemy. Pip install followed by SQLAlchemy, where I see the first 4 characters are in uppercase and followed by the next 5 characters, 6 characters are in lowercase. Who will know all these things, guys? So this is not lowercase, uppercase, proper case, camel case. No, it is mixed case. I have the characters both in uppercase, lowercase. So unless if you visit this .pypi repository, you will not find the solution. The best practice of installing a package is visit .pypi. You have to visit this repository, copy the command, go back to the IDE, paste it, and click on enter. When you click on enter, you see under execution and it is done. What does it say? Anyhow, I have it in my system. It says requirement already satisfied. So that means I already have in my PC. So when you already have, you'll get a message in this way. When you don't have a package, when you don't have a module, when you install it, you'll get a successful message. That is different. When you are doing for the first time, you'll get a successful message. When you are installing the same package for n number of times, you'll get the same message, requirement already satisfied and the location of the package, followed by the version 1.4.25. But what is the current version? It is 2.0.41. Is it clear or not? Why am I taking lot of time to explain the concept of packages is, under data visualization, we will be working on packages. Okay, we will be working on multiple packages and multiple functions from packages. Nothing but obviously you are going to use the functions from modules. So if it is clear, we can go ahead. Yep, shall we proceed? Yes. Let's proceed to the next topic. What am I doing? I'm importing pandas as PD. Done. And we know Pandas is for data manipulation. Pandas is for data manipulation. Done. Then next to it, what is the next package that we are importing? We are importing a package called numpy. What is it? Numpy. Numerical Python. Numpy stands for numerical Python. Numerical Python. Right. Then what we are doing? What is the purpose of NumPy? NumPy is used for basic mathematical calculations. Basic mathematical calculations. So that means the functions that we have in the modules of NumPy, okay, they are generally related to mathematical calculations. And what am I doing? I'm importing NumPy. So from PC, I'm importing NumPy. And I'm giving an alias name as NP. Okay, so that means NP is universal standard. Universal standard. Right? So I'm importing NumPy. Like how we have pandas, in the same way we have NumPy. But the purpose of pandas and NumPy are different. For data manipulation and in order to work on arrays, array concepts. Okay, so in order to work on array objects or in order to perform basic mathematical calculations, we use NumPy. We use NumPy. So I'm importing NumPy as NP. Is it done? Yes, it is done. It is done. Clear? Yes. Then next to NumPy, what do we have? We have matplotlib.pyplot. Hold on. What is this matplotlib? Matplotlib is a package. It is a package which we use for data visualization. Which we use for data visualization. Fine. Then what about pyplot? Matplotlib is for data visualization. What about pyplot? Pyplot is a module. It's a module. Or it can also be a sub-package. Right? See, within a folder, if you have again a folder, instead of having .py files, if you have a folder, this will be a sub-package within the package, right? Yes. But if this pyplot is a .py file, it becomes a module. So what am I doing? I'm importing matplotlib.pyplot. What does that mean? Am I importing matplotlib or pyplot? What am I importing, guys? What am I importing? Am I importing matplotlib or pyplot? What exactly are we importing? Using import statement, am I importing matplotlib or pyplot? We are importing pyplot, not matplotlib. If I want to import matplotlib, why should I use pyplot in the picture? See, I can directly keep it as import matplotlib. This means we are importing matplotlib, like how we have imported pandas, numpy. In the same way, we can import Matplotlib in this way. But is that what we have mentioned here? No. We kept it as matplotlib.pyplot. We are importing pyplot from Matplotlib. And to this pyplot, we are giving an alias name as PLT. Fine. Matplotlib is a package for data visualization. Good. But what is the purpose of pyplot? First of all, why didn't we import Matplotlib? Why are we importing pyplot? Again, the question raises, right? So, import Matplotlib. There is a lot of difference. This is very important. Focus. Import Matplotlib is one line, and the second line is import matplotlib.pyplot. What the differences you observe here? The differences between line 1 and line 2 is, here we are importing a package. The entire package is being imported. But here a sub package or a module is what we are importing. We are importing pyplot, not Matplotlib. That is one thing you have to focus. And what is the main difference? This anyone can observe, right? When we observe, obviously we can get the difference. But anything else, can you comment here? What might be the difference between these two? Anything else? Come on, guys. What is the other difference that you observe here? I can clearly understand that we are importing Matplotlib. And here I am importing pyplot. I can understand. When I go through the code, the lines of code, I can understand it. But what is the main difference? That's what. I can understand that it is package, sub-package and all. But what is the main difference? There is a concept called memory optimization. There is a concept called memory optimization. What is this memory optimization? That is fine, my friend. That's what I'm telling. In the second line, we are importing pyplot. In the first line, I'm importing matplotlib. I can understand it. But you see here, in real world, we follow the concepts of memory optimization. What does memory optimization means? The memory that the Python session memory has, we should keep it free as early as possible. Yes. So assume that, very good. Assume that Matplotlib is a 100 MB folder. Assume that Matplotlib is nothing but a package, right? Package is nothing but a folder. So assume that Matplotlib is 100 MB folder. So what does that mean? You are importing a 100 MB file, a folder to memory. So 100 MB of this memory gets occupied? Yes. But here in line 2, am I importing Matplotlib? No. I'm just importing pyplot. Pyplot can be only 10 MB file. It can be just a 10 MB file. So what you are doing in line 2? I'm just, importing pyplot which is of size 10 MB. So how much difference you see? 90 MB. So whatever you want, I just want only pyplot because all the functions that are related to visualizations are present in pyplot. So instead of importing matplotlib into the memory, let us import only pyplot so that the memory consumption will be very less, our performance will be very high. We know the trade-off, right, between memory consumption and performance, the execution time. So this is very important. Why? Because if you see here, you can also ask the same question. Pandas, numpy, both the packages were imported. The entire packages were being imported. But why we are not doing the same for pyplot is, these packages are less in size. As we go on, there are multiple very big packages. Okay, very big packages. And if you import that package together, there is no use. What is the use of having the rest of 90 MB, files in the memory? No use. That is why whatever is required, we import only those, things into the memory. Whatever is required, I'm importing only those. And I'm optimizing the memory. When I optimize the memory, what happens? The performance, the execution time will be very fast. So that is why you see, import matplotlib.pyplot. And to this pyplot, we are giving an alias name. What is the alias name that we are providing? PLT. So that means instead of using pyplot every time, I'll directly use PLT. I'll not use pyplot. Alias name will be used. Done. And the last line under the packages is importing Seaborn as SNS. We are importing Seaborn as SNS. What is Seaborn? Seaborn is also a data visualization package. It is also a package for data visualization. Then what is the difference between Matplotlib and Seaborn? Matplotlib is a basic package and Seaborn is an advanced package. Okay, so that makes the difference between Matplotlib and Seaborn. That makes the difference with Matplotlib and Seaborn. So I hope it's clear. Now let me also execute line number 4 and line number 5. Is it done? Yes. So I have imported all the necessary packages to the memory. Now I'll start my, journey. I'm going to start the journey. So first of all, I should have some data, right? In order to visualize anything, we should have data. So the data that I'm going to take here is iris dataset. How many of you are aware of iris dataset? If you are from computers, especially AML, data science background, you guys must be aware of iris datasets. Iris dataset, my bad. Where you'll have 5 columns: sepal length, sepal width, petal length, petal width, and variety of the flower. So, do we have any of the folks who are aware of iris dataset? In total, you will have 5 columns and 150 rows. Each row talks about a flower. The flower dimensions. Yes. Sepals and petals. What is a sepal and what is a petal? Any idea, guys? What is a sepal? What is a petal? What is a sepal? Sepal and petals. Probably, yes, I can take it. Fine. Let me take it. You see here, sepals are nothing but, First of all, petals means for the flowers we'll have the petals, right? So that is what you see in the image. These are the petals. And sepals are the protection to the petals. The outermost layer. They are called sepal. Okay. So in this data set, we have three different varieties of flowers. Setosa, versicolor and virginica. These are the three different flowers, and we have the data related to these three different types of flowers. Okay, so I'm going to use this data and I'll be visualizing, the data. I'm going to visualize this data. So how should we, first of all, read the data? The data should be read by taking the path or the location of the file. I have the data present in a CSV file. What is the file name? CSV, comma separated values file. So get the location of the data. This is the location of the data set. Okay. And where am I using it? I'm keeping the location, the path of the file in a function called read underscore CSV. Read underscore CSV is a function. But from where are we using this function? We are using this function from PD. What is PD? PD means pandas, guys. PD means pandas. So that means from pandas, we are using a function called read underscore CSV. And the purpose of read underscore CSV function is to read the data that is present in a CSV file, comma separated values file. Okay, so hope it's clear. And if you see, in order to mention the hierarchy, I'm using dot pd dot read underscore CSV. So that means from pandas, we are using a function read underscore CSV. The dot represents hierarchy, the level. From pandas, the function read underscore CSV. Done. Then what is this R representing? What is this R representing? Go for a guess. What is R representing in line number 8? Any idea? Go for a guess. So this is the purpose of R. Good. R is not exactly, it is not talking about the read. In open function, we have modes. Do you remember open function? Anyways, in Python, there is a inbuilt function called open. For open function, we have modes, in which we have multiple modes like read, write, append, create, right? Write binary, read binary and all. So the R that we have in open function and the R that we have in read underscore CSV. This is not actually part of read underscore CSV. The R that we have before this path, the file path, represents to read the path in raw format. It is especially talking about to consider this path in raw format. Why in the raw format? Because if you observe this path, the file, what do you see? You see some backslash characters. Special characters, backslash is used? Yes. Then what is the purpose of having them? In general, in the path, in the locations, we'll have backslash, right? But in Python, we also have special characters like backslash n, backslash t. What is backslash n? Backslash n is a new line character. Backslash t represents tab space. So in this way, there are multiple special characters, and if your path contains any of these special characters, what happens? You'll get Unicode error. You'll get exception called Unicode exception. Because of that, you can't read the data that is present in this path. For that reason, we use R. R tells to the interpreter that to consider this path in raw format as it is. Don't consider any special characters. No. I hope you are getting my point, guys. Because assume if my name is Nikhil, obviously what we do, we'll change our names, the folder names. So backslash Nikhil will be one of the folder in the path. C colon backslash users backslash Nikhil. So when the PVM, when we execute this line, what happens is Python virtual machine will go through this and it finds backslash n. Yes. So what is backslash n? Backslash n means new line character. So instead of considering these special characters as special characters, we are representing R, which means it tells to the PVM, Python virtual machine, to consider this entire path, the entire location, okay, in the strings, in the quotation marks as raw format. Take it as it is. Don't consider as any of the special characters. In simple. So when you execute, what happens? Obviously, the data that is present in this file will be read, and that data gets stored in a variable called iris underscore data. Where can you see this iris underscore data? In variable explorer. In variable explorer. So let me do it. Done. It is done. You see here. What is the type of that variable? It is data frame. What is data frame? Data frame is representing a two-dimensional Python object. It is a two-dimensional Python object which is similar to table, rows and columns. If you see, data frame is a two-dimensional object which has rows and columns. Even in a table, you will find rows and columns. Yes. In the same way, how many rows we have? 150 rows. How many columns? 5 columns. Okay. Can I also get the preview of the data? Yes. Double click on it. When you double click on it, you will have the preview. You can you can have a look on the data. See. All the 150 rows. I'm able to view the data within Spider. I need not go back to the file. And then I need not come back to Spider again. These things are not required. Especially if you are using Spider, this is the advantage. Any variable can be viewed. See, I'm done. So what I'll do? So data has been read. Data has been read and it got stored to the object. Now, before we start visualizing the data, I'm going to get the information about the data set. I'm going to get the information about the data set. For that, we are using a function called info. We are using a function called info. What is the purpose of info function? Info function will return the information about number of rows, number of columns, then the column names, column D types, data types, and non-null count. Non-null means it is also talking about the missing values, the number of missing values in the data. Clear? So let us execute this line. The syntax is very simple, guys. Data frame object dot info function. This is representing a data frame object, right? It's a data frame object, a two-dimensional object. So I'm going to get the information about this data frame object. So let me do it. Now I'll go through the output of info function. See, how many rows? 150 entries starting from 0 till 149. What is this representing? The index. It is representing index. In Python by default the indexing starts from 0. So 0 to 149 is nothing but 150. In total there are 150 entries, 150 rows. Coming to columns, total 5 columns. So the index for the 5 columns is given here, 0 to 4, and the column names are being provided next to it, and the non-null count. That means all of the columns have 150 non-null, no null values. There are no null values. And D type, in D type, we see the first 4 columns have float values and variety column has object type values. Object is nothing but categorical, non-numeric. Clear? So this will be the output of info function. In order to get the information about the data set, you go and just use info function, you'll get the complete information. That's it. Right. Now, let me start with univariate plots. Let me start with univariate plots. What do you mean by univariate plot? What is the meaning for univariate plots? Univariate is nothing but uni means one. Variate represents a variable column. So visualizing plots on one column at a time are called univariate plots. I repeat, univariate plots are the plots that we visualize on one column. On one column, we visualize the plots. So such kind of plots are called univariate plots. Yes, only on a single column. Right. So what am I doing, guys? First plot that I'm going to consider is bar plot. What is a bar plot? Bar plot is a plot that we generally visualize to understand the data distribution. In order to understand the data distribution, we visualize bar plot. Okay, but bar plot has a disadvantage. What it is? Bar plot cannot be visualized on high dimensional data. When your data has more than 100 records, bar plot is not an ideal plot to understand the distribution of the data. But in this world, can you have a data more than 100 records? For sure. For sure, we have data more than 1,000,000 records. huge amount of data is being generated, right? Then if that is the case, bar plot is not an ideal plot to understand the distribution of data. No. Then we also have other plots, guys. No worries. There are multiple plots which helps us to understand the data distribution. How is the data distributed? Can be understood by multiple plots. One of the plot is bar plot. And bar plot has a disadvantage, a challenge. Right? Yes. So generally on large data sets, we don't visualize bar plot. It is waste of our time. Why? The bars that we have in the plot will be converted as lines. When you have lines in the plot, we cannot interpret anything. We cannot understand, first of all. So what am I doing? Anyhow, my data set size is 150 only, right? So let me go and visualize the bar plot and see how the bar plot looks like. For that bar plot, in order to visualize a bar plot, I'm using a function called bar. I'm using a function called bar. Yes. Where is this bar coming from? The bar is coming from pie plot. PLT is representing what? We have pie plot which got imported. We gave an alias name PLT. So PLT dot bar. So it is representing hierarchy. From pie plot, I'm using a function called bar. Yes. In which we have to pass two positional arguments. Okay. So two positional arguments are mandatory in this function. What are they? One is height column, one is height parameter, and the other one is x. And the other one is x. For the height parameter, what are we passing? We are passing a column. So from data frames, from data frame object, in order to access a single column, we generally use two different types of syntaxes. Can you tell me the syntaxes that we use to access a single column from data frames? Data frame object dot column name or column 1. This is one syntax. If not, data frame object of column 1. This is second syntax. You can use any of these two. What am I using? I am going with syntax 1. That means from data frame iris underscore data, I'm accessing only a single column. What it is? Sepal length. I'm accessing a single column. So this column data will be given to the height parameter. The sepal length column data will be given to height parameter. Okay. Then what about x? X represents the sequential numbers. So what is the size of sepal length? Tell me the size of sepal length column, guys. Size of sepal length column. Overall data frame size is 150 rows, 5 columns. Out of which I am asking you only the sepal length column size. What is the size of sepal length? 150 comma 1. Am I right or wrong? How many columns? Only one column. For one column, how many values you have? 150 values. Understood or not? See, for sepal length, we have 150 values. For sepal width, we have 150 values. Okay. For petal length, we have 150 values. For petal width, we have 150 values. Right. So in total, the size is 150 by 5. In the same for the last column, variety column. How come it is 150 by 5? Every column has 150 rows. Focus. So I'm passing 150 values to height, right? In the same way, you should also give 150 values to x. 150 values to x parameter. Okay. So how am I able to do it is using np.arrange. np is numpy dot arrange is a function which helps us to generate sequential numbers starting from 1 comma 151, which means the starting value is 1 where the end value will be 150. How many values in total? Here also we are passing 150 values to x. So when you pass both these values and when you execute line number 15, you will visualize a bar plot on which column? Sepal length column. You'll get the bar plot on sepal length column. So let me do it. See, this is my bar plot on sepal length column. Are you able to understand anything? Not exactly, because the bars that we have in the image, they are just squeezing and they are going to convert as lines. Because of this, you are unable to interpret the results properly. The challenge of bar plot. Further, in order to overcome the challenge of bar plot, we also go and understand histogram. There is one more plot called histogram. To understand the drawback, to address the drawback of bar plot, we have histogram. Right. Anyways, let us complete bar plot first of all. So what if I don't pass 150 values for x? How many values am I passing here? 1 comma 150. That means we are passing only 149 values. When you pass only 149 values for x and 150 values for y, nothing but height, you'll get error. You see here, shape mismatch error. Shape mismatch error is what you see. So ensure that you pass the same number of values for both x and height. If not, it will throw us an error. Anyways. Next to it. In the next line, what are we doing, guys? Understand it? Understand the next line? I'm going to plot a bar plot. plt.bar. Then, what is the column that we are going to visualize? For which column are we going to get the bar plot? Petal length. On the petal length column, we are going to get the bar plot. And instead of passing np.arrange, I'm using the range function. Range data type. You remember range data type? Under sequence category data types. What is the purpose of range data type? Yes, 0 to 149. That's perfect. What is the purpose of range data type function? I mean range data type. What is the purpose? To store positive integers. Fine. So this will return me, range of 150 will return me 0 till 149. Yes, it's not exactly generating. Yes, it is to store positive integers. Right. You're right. So here we are going to get a bar plot on petal length column. For the petal length column, so this is the bar plot. Even here I am not able to understand the distribution. The data distribution probably I am unable to interpret. I am unable to interpret the results. So what I'll do is to address the drawbacks of bar plot, we have histograms. How is histogram addressing the drawback of bar plot? Is, histogram converts this values into bins. It groups the data. Instead of giving the value, for each and every value, you'll get a bin for a group. That is what we are doing here. So I'm using hist function. The purpose of histogram is also for understanding data distribution, guys. We'll understand data distribution. So I'm using hist function from PLT, pyplot, and on which column are we going to visualize? Sepal length column. Hist is the function and we are going to visualize histogram on sepal length column. Am I passing anything else? No. I'm not passing anything. I'm going to visualize the data. See. You see here, instead of getting bars earlier on the same column, what did we got? We got bins. This is one bin. This is the other bin. Third bin, fourth bin, fifth bin, sixth bin, seventh, eighth, ninth, and 10th. And 10th. First of all, why did we get 10 bins? Did I tell anywhere? Did I specify the number of bins as 10? No. I did not specify number of bins as 10. But still it gave me 10. Why didn't it give, it did not give me 100 bins? Why only 10? We'll understand. Then coming to the data distribution, you see here the data got started in this way, and it stopped. You see a line, a curve, a tail. Yes. You'll see the tails. It is default. Good. Where it is default? How come you know it is default? The default value is 10 in histogram. The number of pins are 10. The default value is 10 is what my friend says. Good. But how did you know, my friend? How you came to know that the value for the number of bins are 10? Anyways, when it comes to the data distribution, I see a long tail, a tail towards right side. This is called right skewed data, positive skewed data. Right? Yes. Now I'll talk about the number of bins. Did I specify anywhere? No. I did not specify the number of bins are 10. And I also did not specify the color blue. But why did I get the color as blue? I can get many other colors, right? I can get yellow color, red color, black color. But why blue color? So in order to answer all your questions, especially for these functions, from the packages that we are using, for these functions we'll have documentation, guys. Very, very important. My suggestion is, before using any function, it's better if you go through the documentation. That would be great. That will be really great. That will be appreciated. How should I go through the documentations? Is you open any of the browser and just keep it as plt.hist. What is plt? PLT in our case is pyplot, but PLT is pyplot in universal standard. It is universally PLT. So we are reading the documentation of hist function, right? So open a browser and keep it as plt.hist. If better, you also mention space documentation. You'll get the link. Matplotlib.pyplot.hist. So when you open this documentation, you see here, Matplotlib is our package. PyPlot, module. From module, what you are using? I'm using a function called hist. That is where you see the hierarchy. Dot. Package, module, function. And you see here, within pyplot.hist function, how many parameters are there? X, bins, range, density, weights, cumulative, bottom, so on. Multiple. But what does the function does? It computes and plots a histogram. That means it plots a histogram. Did we get histogram? Yes. We got histogram. Then scroll down to the bottom. You will find parameters. The explanation for parameters. What is the parameter that we are interested in? Bins? Yes. So did I pass any value for bins in the line of code? No. I didn't pass any value. What values does bins take? It takes int values or sequence of values or str values are supported. But when you don't pass any of these values, the default value will be 10. Okay. That is why we got 10 bins. Why did I get 10? Why not 100? Why not 1000 bins? Is documentation. Everything you'll find in the documentation. And my advice is also to go through these functions before you use. Okay, when you use these functions, obviously when you go through these documentations, you can play with the parameters, guys. You can play with the parameters. The default value is 10. That is why I see 10 bins in histogram. And in the same way, the color, the default color will be blue. Okay. So even if you see here, I'm going to get the histogram for petal length column. Petal length column. Okay. So let me do it. Do you find the same 10 bins? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, Matplot, not only Matplotlib, to be honest, as I am working in the space of AI, AI is very interesting. Because of AI, I started learning Python, and today, we are when we go through the documentations, our concepts will be very clear. So when you have your concepts very clear, you can play with these parameters. You can play with the script. So just think of, guys, when you are clear on the concepts and if you do good amount of projects, you can expect a very good package. Okay, so that is why, in order to do a kind of service, we are conducting these sessions. Utilize these sessions. Okay, I can understand that many of you are, you are parallelly studying and you are attending the sessions. But at least at some point of time, you have to utilize these sessions. If not, you have everything in your hand. But in order to make it as an output, you are the one who will be doing it. Anyways, I'll not go out of it, but when you go through these documentations, your topics, your basics will be very clear. So the range, the density, not everything is important. That's what I'm telling. Not each and every parameter present here is not important, but a few are important. What is X? X is nothing but the data. The input values, this takes either a single array or a sequence of arrays which are not required to be of same length. What am I passing? I'm just passing a single column. I'm just passing a single column. Accepted. So that means I'm passing X. This is X. Right? Did I mention that this is X? No. But still, how it is able to take positional argument, mapping based on the position. So this value iris underscore data dot sepal length will be taken by X. How? Based on position. When you'll understand all these, when you are clear on the basics, for sure you'll understand each and every point that I'm discussing in the session. Right? Yes. I'll go back and I hope you are clear on the histogram. But this time we'll do one thing. Instead of creating a default histogram, why don't we change the parameters? Let us change a few parameters and see. What am I doing here? I'm going to use a function called figure. There is a function called figure from PLT, pyplot. So that means within this pyplot, there is a function called figure. You have to search for figure. Figure function. Where do I have figure? Yes, I see the function figure here. What does figure function does? It creates a new figure. The purpose of figure function is to create a new figure or activate an existing figure. So that means it will create a new figure. That's it. And what am I passing inside it? I'm using only a single parameter called fig size. Nothing but figure size. Fig size. Yes, I see the parameter fig size. What does fig size means? Fig size means passing width and height in inches. To pass width and height in inches. What if I don't pass? So in general, the width and the height, they are allowed in float values directly. If I don't pass any of the value, the default value for width will be 6.4 and for height it will be 4.8. Okay, but I don't want 6.4, 4.8. I want the width to be 8 and the height to be 5. So let me execute this. So this is my figure. It created a new figure of size 8 by 5. 8 is width, 5 is height. Done. I'll talk about, I'll do it again one more time. Next to it, I'm going to create a histogram. I'll take the same column, that is sepal length, and the bins. I don't want 10 bins. Instead of bins being 10, let us define our own bins. Let me define my own bins. So how many bins will I get here, guys? How many bins will I get? How many bins are we going to get here? Will it be 5? How many of you say 5? Okay, everyone says 5. Since we have 5 values, it doesn't mean 5 bins. No. From 4 to 5, it will be 1 bin. 5 to 6, it will be the other bin. 6 to 7, third bin. 7 to 8, fourth bin. See, in order to form a bin, you should have two values, a lower value and upper value. A lower value, upper value. A lower value, upper value. So nothing but maximum, minimum, maximum, minimum. So that means here we are defining the ranges of our bins. It is 4 guys, not 5. And the color of the histogram, I want it in red color. Okay, instead of keeping it blue, I want it in red color. The edge color should be black. For each and every bin, the edges of the bins should be in which color? Black color. So I can play with the values for the parameters. Next to it, I'm going to pass an X label. What is X label? It is again a function in pyplot which gives us a label for x-axis. To the x-axis, it will give this name. What is the name? What is the column that we are using? Sepal length. So sepal length will be given as a label for x-axis. In the same way for y label. Y label is a function from PLT, pyplot. So for y label, the label will be, for y-axis, the label will be frequency. And to the overall plot, I'll get the title as histogram of sepal length with custom bins. This will be the title. Title is the function coming from PLT, pyplot. And finally, show function from PLT helps us to display the plot. So that means I'll execute from line number 24 till 32 together. I'll get my customized histogram. What I'll get? I'll get customized histogram. See. Understood? Earlier also we got histogram. This is also a histogram. But what makes the difference? This is my customized histogram. How many bins you see? Only 4. 4 to 5, 5 to 6, 6 to 7, 7 to 8. Then color of the histogram should be red color. Edge color should be black color. X label is sepal length. Y label is frequency. The title is histogram of sepal length with custom bins. Okay. And I have kept this entire plot in a figure. So this is how we customize the visualizations. But when can you customize? When you go through documentation. When you go through documentation, only then you'll understand the importance of parameters, guys. If not, no. Anyways, I hope this gave us a lot of information regarding histograms. Right? Yes. Now let us go to the next plot called as box plot. What is the next plot called? Box plot. Box plot? Yes. What is box plot? Box plot is also called as whisker plot. Box plot is also called as box and whisker plot. What is box? What is whisker? Means the box that you see in the middle. This is called box. Because of this, it is named as, the plot is named as box plot. And the tails that you see here are called whiskers. They are called whiskers. Because of it, the plot is named as whisker plot. Since we have both box and the whiskers, it is called box and whisker plot. So any of these three means same, guys. What is the purpose of box plot? Histogram helps us to understand the data distribution. But what is the purpose of box plot? Box plot helps us to understand, visualize outliers. Outliers? Yes. Outliers are nothing but extreme values. Any example? Yeah, sure. You take salaries of employees. In an organization, we generally have employees, right? When you take the salaries of employees, will each and every employee will be paid same? No. Upon the skill, upon their experience, the salaries change. The salaries vary. So, the packages, the salaries of managers, CEOs, MDs, they'll be very huge. Yes. So these people will be extreme values. They'll be outliers in salaries column. Probably this side. And these outliers will be represented as circles. We'll also have interns. We'll have interns. So for intern, again, the salaries will be very less, very small. So they also will be outliers. They will be outliers again. Towards which side? Towards the reverse direction. Opposite side. So the extreme values are called outliers. These are called outliers. In order to understand the outliers in the data, we visualize a plot called box plot or whisker plot or box and whisker plot. Okay, then are there any parts for this box plot? Yes. This is called lower limit and this tail is called upper limit. Lower limit, upper limit. So any value beyond lower limit or any value greater than upper limit will be extreme values or outliers. They are called outliers. Okay, what about the box? To the box we have Q1. This part is called Q1, 25th percentile, Q2, 50th percentile, Q3, 75th percentile. It assumes that the data has 100% of the data, right? And Q2 will be nothing but median. It will be median. Q2 is nothing but median. So this 100% of the data will be divided into 4 parts. That means 25% of the data lies between lower limit and Q1. The first box will be 25%. Second box contains 25% and that between Q3 and upper limit again it takes 25%. So that means exactly if I take this box plot into 2 parts, 50% of the data one side and the 50% of the data towards other side. So box plot, apart from talking about outliers, extreme values, it also talks about data distribution. The primary goal of box plot is to explain about outliers, to visualize outliers. The secondary purpose of box plot is to understand the data, to understand the data distribution. That is why we visualize box plot. What is the reason behind it? This is the reason. So let us visualize a box plot and probably then you'll understand. What am I doing, guys? In line number 35, plt.boxplot. From matplotlib.pyplot, we have imported pyplot as plt. Yes. we have imported Matplotlib as PLT. Then what am I doing? I'm going to visualize box plot on which column? On sepal width column. Right. I'm going to access a single column from iris underscore data. Okay. And I'm accessing the values of only a single column. So that means we are going to visualize box plot of one column. So box plot comes under univariate plot. It comes under univariate. We are visualizing on one column at a time. So let me visualize box plot. This is my box plot. Do you see outliers? Yes. Towards which side? Towards upper limit and towards lower limit. Towards both the sides, I see outliers. Right? So this is box plot, guys. Box plot is the only plot which talks about outliers. We can visualize outliers only using box plot. Anyways, I'm going to visualize box plot on the same column, but this time using SNS. What does SNS mean? SNS means Seaborn. SNS means Seaborn. Using Seaborn, the function box plot, it is present in both Matplotlib and Seaborn. So we have discussed earlier, Matplotlib is a package which helps us to visualize data, but it is a basic data visualization package. But Seaborn is an advanced data visualization package. Right? Yes. So I'm going to visualize the same box plot on sepal width column. I'm going to visualize box plot on sepal width column, but from Seaborn package. Let us see the difference. Yes, I see the difference. Earlier, the box is not shaded, but this time I see the box shaded, and moreover, the box is, it's elongated. And I see circles. There it is dots, right? So that means towards both the ends, we have outliers in sepal width. Let me do the same on petal width. Let us visualize outliers on petal width column. Using PyPlot, Matplotlib. Do you see any outliers? Do you see any outliers? No outliers in petal width. But in sepal width, there are outliers. Right? And I'm going to visualize the same plot, same box plot using Seaborn on the same column. I'm not changing the column, guys. I'm just changing the, package. Earlier it is Matplotlib, now Seaborn. See. Okay. So with this, we have also completed box plot. We are done with univariate plots. We are done with univariate plots. Now let us understand bivariate plots. Okay, let us understand bivariate plots. Under bivariate plot, we have only a single plot called as scatter plot. What it is? Scatter plot. What is the purpose of scatter plot? Scatter plot helps us to understand the relation between two columns, two features, two variables. Okay, in order to understand the relation between two columns, we go and use scatter plot to visualize a scatter plot. How does scatter plot helps us to understand the relation between two columns? Is it will plot the scatter. Okay, we'll see a scatter in this way. One column will be taken on x-axis, the other column will be taken on y-axis. One on x, the other one on y. Okay, and scatter plot will give us the information about three main things. One is about linearity, then direction of spread, and the third one is strength. Let us talk about all these three. In order to understand the relation, you have to understand these three. Linearity. Is the scatter linear or non-linear? You see here, this is linear case. If you have scatter in this way, between the two columns, if you have scatter in this way, this comes under non-linear. Then coming to the direction, either you'll have upward direction or downward direction. In some cases, no direction. This you see, as x increasing, what's happening to y? Y is also increasing. Upward direction. In some cases, you will have scatter in this way between the two variables. This is called downward direction. That means as x increases, what's happening to y? Y decreases. That is what you can understand from direction of scatter. Coming to the third one, strength, third important point. Okay, let me also talk about no direction. In some cases, you'll have the scatter in this way. Okay, so no direction. You'll not have any upward direction or downward direction. That will be no direction. It means constant. Coming to strength, strength talks about the scatter spread. How close the scatter is. Is the scatter tightly packed? Is it very close to each other? Or this is case 1. Or you see the scatter moderately spread. Instead of packed tightly, you see the scatter packed moderately. If not, do you see the scatter very loose? So where you see here and there, this is very loose. Accordingly, the strength will be decided. Strength is talking about, the strength between the two columns. Is the strength strong, weak, or moderate? Can be commented. We can make a comment based on the scatter spread. Right? So if the scatter is very close to each other, if the scatter is tightly packed, then we say we have a strong relation between the two columns, the two features. If the scatter is very far afar, you see here and there, not closely packed, one here, one there. So that we can say that as weak strength. There is no kind of relation between the two columns, two features. Then when do you say moderate? It is not tightly packed. It is not closely. It's not even far from each other. Between these two. That will be moderate case. But here comes the problem. For me, this will be strong. I can tell this is strong for me. But you guys can come and tell, no, this is moderate. The strength is moderate. Because this is a visualization, right? Scatter plot is a visualization. When you visualize something, everyone will have their own perception. They'll take their own call. So there comes the issue. Strength is subjective in nature. Strength is subjective. Every one of us will have own decisions. You'll take your own call. For me, this is strong. But for you guys, it is moderate. Who is correct then? Their scientists or statisticians have introduced the concept of correlation coefficient, small r. In statistics, there is a concept of correlation coefficient. What is the purpose of small r? Small r made this strength objective. How? Small r ranges from -1 to +1. The range of small r is -1 to +1, where minus and plus indicates direction, guys. Okay, minus and plus is indicating direction. Perfect. Minus means negative direction, downward direction. Plus means positive direction, upward direction. Fine. So if I take magnitude, if I take mod of r, the range of r will be 0 to 1. Yes. Obviously, the range of r will be 0 to 1. So, taking the mod of r, that is magnitude of correlation coefficient, our statisticians, they have come up with some thumb rules. What are the thumb rules that I have come up is r greater than 0.85 means strong correlation between the variables. R greater than 0.85 means strong correlation between the variables. Okay. R less than 0.4 means weak relation between the variables. The strength is weak. R lying between these two ranges, 0.4 less than, greater than R less than 0.85 means moderate relation. Okay, so that is the purpose of small r. Very important, especially in interviews. If you are from statistics background, you can expect a question from correlation coefficient. AML, data science, one of the important topic, guys. Correlation coefficient, what is the purpose of it? Even correlation coefficient is actually it is helping us to understand the relation between two features. What is the relation? Strong, weak, or moderate? How is the direction? So, without visualizing scatter plot, by just getting the small r value, I can take a call on these two things. Direction and strength, yes. Yes. But linear or non-linear should be decided only after visualizing scatter plot. You cannot you cannot comment about the linearity by just calculating small r. No. I hope it's clear, right? So this is the concept behind scatter plot. What is the purpose of scatter plot? Scatter plot helps us to understand the relation between two variables. That is why it is a bivariate plot. Bi means two. Two columns, variate columns. Two columns we take and we visualize a plot. Those plots are called bivariate plots. One of the widely used bivariate plot is scatter plot. Very, 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 very important. So let me talk about a bivariate plot. Here we have an example. Again, taking figure function from pie plot and the figure size is 10 by 8. 10 is width, 8 is height. Done. Scatter. In order to visualize the scatter plot, the function that we use is scatter. For scatter plot, the function is scatter. Coming from pyplot. Pyplot dot scatter, where two parameters are mandatory. What are they? X, Y. X, Y. So tell me guys, what are the two columns? Petal length, petal width. For x-axis, which column are we taking? Petal length. For y-axis, petal width. And the color of the scatter should be green. So I don't want to go with the basic color, the default color blue. I want to change the color to green. Yes, okay. X label, the function from pyplot will give us a label to our plot as petal length. It gives a label called petal length to our x-axis. And Y label function will give a label petal width to y-axis. The overall title for the scatter plot will be correlation between petal length and petal width. It's very simple guys. Python is very simple if you understand the fundamentals. Okay, when your fundamentals are very good, you can play with these, the code. So all of these we are using from the packages only. Matplotlib.pyplot. Title is a function. Okay, and finally show function from pyplot to display the scatter plot. So let me run all these lines together. I got the scatter plot. I got the scatter plot. Petal length, petal width. X-axis, y-axis. A scatter plot is a bivariate plot. So two columns. Now tell me the direction first of all. Direction. For this scatter plot, tell me the direction. The direction for this plot is upward. Good. See guys, in which direction is the scatter? It is in upward direction. Positive. Positive direction, upward. So that means as petal length increase, what's happening to petal width? Petal width is also increasing. Okay. Let us comment on linearity. Do you see linear or non-linear shape? Do you see linear or non-linear shape? Linear. Let me draw it. Is it linear? Yes. Good. Good. Now, finally, the last one. I want you guys to comment on strength. Comment on strength. Is it strong, weak, or moderate? What is your answer? What will be your response? Okay, my friend says moderate. Why moderate, my friend? Why it is moderate? Why it is moderate? Okay, all of my friends is moderate. Good, good. Keep going. Okay, so probably 6 votes for moderate and 1 vote for strong. Plus 1. Keep going, keep going. Plus 1, plus 1. So, majority of my friends is the relation, the strength between petal width and petal length is moderate. Why? Because of the space, probably. And moreover, scatter plot will also give us the information about clusters. What do you mean by clusters? Groups. This is cluster 1 and this is cluster 2. That is why you see the clear difference. You see here the space between the groups. So because of that, my friends, all of us are commenting that the strength between the two variables is moderate. So we have already discussed strength is subjective. Strength is subjective. Because of this, all of us will have our own answers. Yes, for me also it is moderate. But how can I make it objective? How can I fix it? Using small r. Using small r. It need not be in a single line. Again, see, you cannot tell every time the scatter which is present in a single line will be strong. No. The scatter, the distance between the scatter should be very less. If it is very less, then you can see, it is strong. But again, we are clueless. Until unless we calculate small r, you cannot take a decision regarding strength. Why? Strength is subjective. So let us do one thing. Let us calculate strength. Let us calculate strength and then we'll understand. Okay? Yes. So in order to calculate strength, we have a function CORR. CORR. CORR represents correlation coefficient function. Okay, this will return us a matrix. As I'm going to perform this function on the data frame, and correlation coefficient will be calculated only for numeric columns. For non-numeric columns, it will not calculate. Okay, so let me calculate correlation coefficient matrix for the data frame. Done. So I see a matrix of size. What is the size? 4 by 4. 4 rows, 4 columns. All the diagonal elements will be, the diagonal values will be 1. Why? The correlation with the same column will be 1. The correlation with the same column will be 1. So you can ignore the diagonal elements, the diagonal values, and you can consider either upper triangle values or lower triangle values. That is enough. So this one or the above one, the above triangle is enough. Between which two variables we are checking? Petal length, okay, and petal width. Petal width is, okay, petal width and petal length. This one. Petal width and petal length. What is the value? The value is 0.962. Now you tell me the relation between petal length and petal width. What is the relation? How is the strength between the variables, between the columns? The columns are petal width and petal length. The strength is strong. Why it is strong? Because R value is greater than 0.85. So just based on scatter plot, we cannot take a decision regarding strength. And it is plus 0.962. That means for sure the direction will be positive, upward side. This is how we interpret the results of scatter plot. So that means petal width is highly correlated with petal length. We have the duplicate information. That is what it represents. Highly correlation. 0.96 is very close to 1. Right? Yes. So that is how we represent, we interpret the results of scatter plot. Can you tell me the relation between sepal length and petal length? The relation between sepal length and petal length. It is strong again. Why? Sepal length and petal length 0.871754 greater than 0.85. Yes, the relation is strong again. Good. Okay, so we have understood both univariate and bivariate plots. Okay, all the important univariate and bivariate plots were being discussed, and your task will be like working on a data set. Take a data set, okay, any open source data set, and try out all these visualizations. Try out all these visualizations. Univariate plots and bivariate plot. Interpret the results. Not just visualizing, you have to interpret the results. Interpretation is very important. Understanding the insights. Clear? Yes. So any questions in the topics that were being discussed in the class? The questions related to univariate plots and bivariate plots. Clear? Good. Right. So in general, the data sets you can find under Kaggle, guys. Okay, in Kaggle, you generally find the open source data sets. There are multiple data sets. So if you want me to suggest, I suggest the data set of COVID-19. Okay, if not Titanic data set, all these are open source. Use them, and you can directly apply the same concepts. Visualize the plots, both univariate and bivariate. Yes, that will be the good task for the day. And one more thing, guys, on 6th of this month, a new internship batch is going to start. Okay, so do share across your connections. A free internship batch is going to start on 6th of June. Okay, do share across your connections. Yes. And we have also pinned the message in the chat. Okay, it is pinned in the chat. Just have a look. Okay, do share across your connections because this is the best opportunity that we are providing, guys. Right? So be part of our internship. Do share at least in your connections so that some of them get benefited. So the best thing that we are going to do from this particular internship is at least 1 hour a day, the trainers will be interacting with the folks. With the interns, the trainers will be interacting and they'll be solving the questions, the queries. So be part of the internship. Thank you so much, guys. And before you leave, if you find that the session went well, hit on the like button and do subscribe to our channel as well and share this amazing session among your connections. Okay, so subscribe to our channel because we are going to come up with amazing content in the future as well. And we have the feedback link posted in the chat. Do, please give your valuable feedback as well before you leave.